Hello, I'm Michael Robb, and welcome to my Research Unpaper project. For my project, I researched the development of AI in video games from simple beginnings to its complex future. One of the earliest instances of machine learning used for game programming came as a result of engineer Arthur Samuel's efforts to replicate the game of checkers using early IBM computers. Hardware limitations of the time inspired him to create a scoring system, or alpha-beta pruning, shown here, in which the program made calculated moves based on its likelihood of winning from a given position and results of past victories or losses. Though these learning methods were primitive at the time, they would inspire researchers at IBM and beyond to continue developing AI that would not only challenge, but surpass human competition. Chess master Deep Blue and later Jeopardy champion Watson would expand on IBM's ideas of applying reinforcement learning to games, as would the rising video game industry. Rewinding the clock, two famous examples of reinforcement learning can be analyzed in Space Invaders and Pac-Man. The aliens of Space Invaders and Ghosts of Pac-Man were both revolutionary in their responses to player inputs. Each game's AI-controlled enemies would become more aggressive as players progressed through the levels, and in the case of Pac-Man, the four ghosts were programmed to behave differently depending on the player's position. These breakthroughs in reinforcement learning made the games more immersive, emphasized by the players who still return to them to this day. In addition to reinforcement learning, the applications of neural networks in video games allowed for even greater immersion value. One such game is Creatures, released in 1996. The creatures in this game, called Norns, are supervised by the player, but the Norns themselves interact with the game world independently and communicate with each other in their own original language. The neural networks powering the creatures adapt alongside them. This is an early instance of adaptive behavioral AI as a core feature of a game. As 3D video games became the norm towards the end of the decade, this framework was applied to NPCs, or non-player characters, in all manner of games, from The Sims to Halo Combat Evolved. As video games continue to evolve, so too does AI research. A recent phenomenon made possible by such research is the prospect of generative AI. Unlike reinforcement learning or neural networks, which are heavily rule-based, generative AI uses a pre-written prompt as an input and from it generates original text, images, or audio. One industry titan, Ubisoft, plans to implement an early tool for this new form of AI, in which speech inputs generate bodily gestures as output. Rather than follow restrictive programming scripts, NPCs trained with this software can react to a player's behavior with less predictability, allowing for even deeper immersion. Another prominent game developer, Monolith, experimented with these ideas several years ago in Middle-earth: Shadow of War. In the game, enemies that survive encounters with the player remember their past battle, allowing for future encounters to feel even more dramatic and intense. In addition to generative AI's potential for more complex, unpredictable NPCs, developers are excited by the prospect of generating entire open worlds for players to immerse themselves in. Until now, open world games like No Man's Sky have relied on procedurally generated content, which relies on pre-programmed limitations to avoid making games unplayable. But with enough playtesting and fine-tuning of player data, it will likely be possible for generative AI to be regularly used to create quests, story beats, and open-world environments with minimal supervision from developers. While all of this sounds exciting and innovative, it will be crucial to take ethical considerations in the pursuit of this new technology. The Screen Actors Guild and Writers Guild made history last year by adding video game companies to their strike list. Many voice actors, motion capture performers, and game writers potentially face job insecurity because of these developments. Diversity is also a cause for concern. Google and Facebook, two AI research moguls, have a female workforce making up 10 and 15% of their demographics, respectively. Additionally, only 2.5% of Google's workforce and 4% of Facebook's is Black, according to research by New York University cited in my Guardian article. These startling statistics are being counteracted by game companies like Electronic Arts, who plan to represent their diverse player base by giving them the power of user-generated content, allowing them to capture their own selves on camera and upload it into the game. To reach ethical solutions and ensure generative AI is representative of all who create and consume it, video game companies must work towards diversifying their teams. This will allow for a greater number of outcomes and ideas to usher in a new era of gaming with increasingly limitless possibilities.